Welcome to MathGPT. Today, we're going to explore our sun, the star at the center of our solar system. The sun is a fascinating celestial body that powers life on Earth and controls the dynamics of our entire solar system. Let's start with some basic facts about the sun. First, the sun is a star, a massive luminous sphere of plasma. It's classified as a G-type main sequence star, often called a yellow dwarf. Despite being average-sized compared to other stars, the sun contains approximately 99.8% of the mass in our solar system. Now, let's examine the structure of the sun. The sun has a layered structure, similar to an onion. Let's visualize these layers from the inside out. The core is the innermost part of the sun. It's where nuclear fusion takes place. The temperature in the core is extremely high, about 15 million Kelvin. Under these extreme conditions, hydrogen atoms fuse to form helium, releasing enormous amounts of energy. Next is the radiative zone. In this layer, energy from the core moves outward through radiation. That is, photons travel outward carrying energy. This process is extremely slow. It can take between 100,000 and 170,000 years for a photon to travel through this zone. Above the radiative zone is the convective zone. In this region, energy is transported by convection. Hot plasma rises, cools at the surface, and then sinks back down. This creates patterns of rising and falling plasma that can be observed as granulation on the sun's surface. The photosphere is the visible surface of the sun. I put surface in quotes because the sun doesn't have a solid surface like Earth does. It's all gas and plasma. The temperature of the photosphere is roughly 5,500 degrees Celsius. Above the photosphere is the chromosphere, which appears as a reddish glow during solar eclipses. Finally, the outermost layer is the corona, the sun's extended outer atmosphere. Interestingly, the corona is extremely hot, between 1 and 3 million Kelvin, much hotter than the photosphere beneath it. What is the sun made of? The sun is composed primarily of hydrogen, about 74% by mass. Helium makes up about 24%. The remaining 2% consists of heavier elements, which astronomers collectively call metals. How does the sun produce its energy? As we mentioned earlier, the sun's energy comes from nuclear fusion in its core. Under the extreme pressure and temperature conditions, 4 hydrogen nuclei combine to form one helium nucleus. The mass of the helium nucleus is slightly less than the 4 hydrogen nuclei, and the difference in mass is converted to energy according to Einstein's famous equation, E equals mc squared. This nuclear fusion process produces an enormous amount of energy. The sun converts about 600 million tons of hydrogen into helium every second. The sun is not a static object. It exhibits various forms of activity. Sunspots are dark, cooler regions on the sun's surface caused by intense magnetic activity. Solar flares are sudden, intense bursts of radiation from the sun's surface. Coronal mass ejections, or CMEs, are massive releases of plasma and magnetic field from the corona. The solar wind is a continuous stream of charged particles flowing from the sun, which can interact with Earth's magnetic field to create auroras. Like all stars, the sun has a life cycle. Currently, the sun is about 4.6 billion years old and is in the main sequence phase of its life. In about 5 billion years, the sun will exhaust its hydrogen fuel and begin to expand into a red giant. As a red giant, the sun will grow large enough to engulf Mercury, Venus, and possibly Earth. Finally, it will shed its outer layers, leaving behind a core that will become a white dwarf. This white dwarf will gradually cool over trillions of years. The sun is vital to life on Earth. It provides the light and heat necessary for life to exist. The sun drives Earth's climate and weather systems, and its gravitational pull keeps Earth and all other planets in their orbits. Here are some key numbers about the sun. Its diameter is approximately 1.4 million kilometers. The sun's mass is about 2 times 10 to the 30th kilograms. Its surface temperature is around 5,500 degrees Celsius, and its core temperature is 15 million Kelvin. The sun is about 150 million kilometers from Earth, a distance we call 1 astronomical unit, or AU. And as we mentioned earlier, the sun is approximately 4.6 billion years old. In conclusion, the sun is an extraordinary celestial body that powers our solar system. from its nuclear fusion core to its extended corona, from its current main sequence phase to its future as a red giant and white dwarf, the sun continues to fascinate scientists and astronomers worldwide. Without the sun, life on Earth, as we know it, would not exist. It truly is the center of our solar system in more ways than one. Thank you for watching MathGPT.